Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it really helps us reach others in need of assistance with these topics. So what we're going to be covering in this video is differential equations, and we are going to be solving a differential equation, the one shown on the screen, by using the separation of variables method. So we have our second order derivative here of y is equal to 20x cubed. So like I said, we're going to separate the variables to solve the differential equation given two boundary conditions of y of 1 is equal to 7 and y prime, which is the derivative of the equation of y, is of 2 is equal to, that equation of 0 is equal to 2. So let's assign a few items here. So when you have y with the two tick marks, what's that mean is that you are a second order differential equation, which means you are d squared y over dx squared. You are the second derivative of the y equation with respect to x. So let's define w as the first order of that, dy dx. So when we assign this variable w to this, that means that the derivative of w with respect to x is equal to that second order of the y equation with respect to x. So what I can do now is I can take this dw dx and plug it into my equation over here for the y, for the second order derivative of y. So let's plug that in. So we would have dw dx is equal to 20x cubed. All right, so now we are going to separate the variables, rearrange. We're going to get like terms on each side. So taking the dx to the right side, we end up with w, or dw, is equal to 20 x cubed dx. Now that we have separated the variables, we can integrate both sides here. So integrate, integrate. So when we integrate both sides, the left side just simply becomes w, and the right side becomes, well, 20 over 4 x to the fourth plus my constant of integration, which technically both sides will end up with a constant, your integration constant c. But since it is a constant, we're only going to throw it on one side of the equation. So let's just go ahead and simplify this down. So we have w is equal to 5x to the fourth plus c. Alrighty, well, what is w? Because what we're looking for is what is my y equation equal to? That's the whole point of this. Well, I have what the w equation is equal to. Well, we know that w is the first order derivative of y. So what we can do is that we can use this second boundary condition that we were given, and we can find that constant c. So let's go ahead and let's do this. I'm just going to move up here with it. So since we have y prime of 0 is equal to 2, that's essentially saying that the w equation of 0 is equal to 2. So when we plug in 0 for our x variable, we will end up with 2 for our w variable given this equation. So that means that I will have 2 is equal to 5 times 0 to the fourth plus my constant. Well, that whole portion disappears and my c pops out to be 2. So my corrected equation, completely filled out, for w is going to be 5x to the fourth plus 2. Well, as I said, we need to have the equation in terms of y. Well, we can just take this and plug it in for w down here. And when we do that, then we are back in terms of the y equation. So we would have dy dx is equal to 5x to the fourth plus 2. So now let's scroll down. So just like what we did over here on the left side, where we separated the variables out between w and x, same thing again, we are going to separate our variables out between y and x. And I'm just going to do this over here. So what we have is that we just take dx to the opposite side, which is to the right side. So we have dy is equal to 5x to the fourth plus 2, all of that times dx. Well, once again, once we have our variables separated, we're just going to integrate both sides here. And the left side is very simplistic. dy integrated just becomes y. And on the right side here, we don't have to use any special chain rule or product rule or anything like that. So we would just have 5 over 5 x to the 5th plus 2x plus our constant. And the same reasoning as before, we just have constants on both sides technically, but we're just going to throw it on the right side because, well, constant plus a constant is a constant. So this is my equation. Let's simplify this down. And it basically just turns into this. Y is equal to x to the 5th plus 2x plus c. And technically this would be c2 because it is my second constant. So that is not the complete answer because, well, we have to determine what our constant is using this first boundary condition that we were given for the y equation of 1 is equal to 7. So just like before, when we plug in here, that means that we would plug in 1 for our x variable, and then the y would pop out to be 7. So we can use this boundary condition to find out what our second constant is. So we would have 7 for y is equal to 1 to the 5th plus 2 times 1 plus my second constant. Well, rearranging here and using simple algebra, what we get is we get c2 is equal to 4. So my answer for my y equation would be x to the 5th plus 2x plus 4. And that would be your answer for this differential equation. And that is what the equation would have to be in order for this expression to be true. Well, what you can do is that you can check your answers. With all differential equations, you can check your answers here. And what we're going to do is that we're just going to plug this y equation back into our beginning expression. So let's go do the check in blue here. So this will be our check. So our initial equation is the second order derivative of y is equal to, or the second derivative with respect to y is equal to 20x cubed. Well, we need to find out what the second derivative of y is, because essentially this is d squared y over dx squared is equal to 20x cubed. So whatever the second derivative of this should equal 20x cubed. So let's plug in y here because we would have our second derivative with respect to x times my y, or of my y, of x to the 5th plus 2x plus 4 has to be equal to 20x cubed. Well, essentially, we're just going to take the derivative of this twice. So ddx of the ddx of x 5th plus 2x plus 4. Well, it should, and we're only going to show the left side for right now because this should pop out to be 20x cubed. So let's do our first derivative here. Well, the first one, well, x to the 5th becomes 5x to the 4th plus 2, and then, of course, the 4 goes to 0. Well, you take another derivative of this one, and 5x to the 4th, so 4 times 5 gives me 20. Lower that power by 1, x third, and then 2 goes to 0. So, yeah, this left side does boil down to what the right side was. If it doesn't come out to be the same, then you've done something wrong somewhere. But that check worked out, so we know that we have our correct answer, which is right here. The y equation is our answer. So I hope this video was helpful. And if you want to see more problem solve this Friday, please check out the other videos on our channels we're trying to upload daily. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel. Thank you for watching, and I hope you have a fantastic day.